Hello everyone. Now I am going to explain you about a Kirchoff's law. So we need to know why we came for a Kirchoff's law rather than Ohm's law. So Ohm's law is the fundamental formula. All the laws will following Ohm's law. But if you want to determine current across individual resistance using Ohm's law, in the sense it is too difficulty, there we need to apply network reduction technique and need to apply a division rule to get the current and voltage across individual resistance. That problem can be easily overcome using Kirchoff's. If you follow Kirchoff's law, the answers is said to be current across individual resistance only. So before going to explain about Kirchoff's law, in a problem, in a question, if they ask you to apply Kirchoff's law, in the sense, there you need to apply Kirchoff's two laws. Kirchoff's will have two laws. The first law is said to be Kirchoff's current law, and second law is called as a Kirchoff's voltage law. So Kirchoff's current law is said as a first law, and Kirchoff's voltage law is called as a second law. And Kirchoff's current law is applicable only on a node point or a junction. So current law is another way called as a junction law. Kirchoff's voltage law is another way called as a loop law. So how we need to identify a junction? More than one resistance connected at a point is called as a junction, or more number of connections present at a point is called as a junction. So more connections meeting point. More connections meeting point is called as a junction. Closed circuit is called as a loop. Closed circuit is called as a loop. So this is the difference between these two laws. But in a question, if ask you to explain Kirchoff's apply Kirchoff's law in a problem, means you need to apply both the laws. Now we need to discuss about the statement of Kirchoff's current law and voltage law. So current law states that at a junction, sum of incoming current, which is equal to sum of outgoing current. So sum of incoming current, which is equal to sum of outgoing current. It means that at a particular junction, if you have n number of connections, so what are all the currents are coming towards the junctions are said to be incoming currents. What are all the currents is going away from the junction is called as a outgoing current. So according to this example, if you apply a Kirchoff's current law, we will get an expression as I1 plus I2, which is equal to I3 plus I4 plus I5. Now we are going to check the same on the Kirchoff's voltage law. So according to it, at a loop, potential drop, which is equal to potential rise. Drop, which is equal to potential rise. In another way, potential drop across individual resistance, which is equal to source voltage. Like this also we can write. As an example, if you have a loop like this, if it is 1, R1, R2 and R3, and the voltage across this resistance I am naming it as a V1, and this is V2, and this is V3. According to this statement, algebraic sum of voltage drop across individual resistance, that is V1 plus V2 plus V3, which is equal to source voltage V. So this is the statement of a Kirchoff's voltage law. Now we are going to check how we need to apply Kirchoff's law in any kind of a large circuits will have a n number of nodes and n number of loops. For the better verification purpose, I am taking the previous problem. So if you have any doubts how to apply Ohm's law in any of the circuit, you can check my Ohm's law video. There I have used the same circuit and determined the current across all the resistance. So here, without using any reduction techniques, without using any division rule, so without converting this complex circuit into a simpler circuit, I am going to determine current across individual resistance directly by using Kirchoff's law. Provided we need to apply Kirchoff's current law and voltage law in the same circuit. Once again, the voltage law should follow Kirchoff's current law orientations. So I'll tell you what is meant by that orientations. First, in a given circuit, we need to check how many loops are there and how many nodes are there. Here also I'll give you one hint. Here we have visible two loops. Always in a linear circuit, node which is equal to loop minus of 1 preferably. Since my loops are 2, so I'll have only one node in the given circuit. So that one node is said to be this node and this node is said to be return node. For the return node, the potential value is 0, so we need not consider that. If I take this as my node, at this node only I need to apply my Kirchoff's current law. According to a current law statement, so I am writing from a source, I am getting a current as in this direction and it is coming to this junction. At a junction, the current splitting will be there. So wherever we have a parallel, there we have a splitting of a current. Here we have a parallel connection. Here the given current is getting split into two halves. Now this is what I am saying. This is what the current assignment. The same current direction law only Kirchoff's voltage law should follow. So while you apply a voltage law, you should not change the current direction which is assigned by Kirchoff's current law. That is the important thing you need to follow. Again, how many loops are there? That many number of loop equations you need to write. I will repeat. How many number of loops we have? Those many number of loop equations we need to write. How many number of loop equations we have? That many number of unknown variables only you need to declare. So here it is 3 current, but here you need not write that 3 current. Here we need to declare only 2 currents. That is the concept I mean to say. I'll tell you how it is possible. So this current I am naming it as I1 current. This is in Ohm's law we will say it as a total current. For the Kirchoff's we must have a difference. So that I am writing this as a I1 current. This I1 current only is getting divided into 2 currents. Here, which is the first current is coming to the source. For that only I need to declare a variable, second variable. So here I am naming it as an I2. Here I need not write I3. Why? Because here itself we have already declared I1, I2, 2 unknown variables, because here we have only 2 loops. Then what type of a current we need to give over here? Here only we need to apply that general mathematics, again Kirchoff's current law statement. According to current law, what it mentions is, I am going to apply current law at node. Here my incoming current is I1 and the outgoing current is I have declared is I2 plus unknown current. So here we need to mathematically verify that I1 which is equal to I2. In some other way, I can say here it is an 100% current. This 100% current is equally divided into 50 and 50. I know 150. Then how I need to write this 50? So 100 minus of 50 we can represent as another 50. So it is 100 is I1 and another 50 is said to be I2. So that these two I2s are getting cancelled. So we have verified incoming current equal to outgoing at a particular junction. So based on this verification, this unknown current I1 minus I2 only we need to substitute over here. This is the only twist we need to follow in a Kirchoff's law. So how many number of loops we have? Those many number of loop equations only we need to write. How many number of loop equations we have? Those many number of unknown variables only we need to declare. So I have satisfied all. I have declared only 2 variables since we have 2 loops only. Using the current law, I have verified and balanced incoming current equal to outgoing current. Now in the circuit, I have successfully applied Kirchoff's current law. Now we are going to apply Kirchoff's voltage law at each loops. Here we have 2 loops, so I am taking from 1. So this is my loop number 1. I am naming this as a loop number 2. Here you can check, always my current flows from negative to positive. It is some clockwise trace. I am following the same clockwise trace. The same clockwise current only flowing through this loop also. So this you need to assign previously. Now I am going to apply KVL at loop number 1. According to the statement, in a closed loop, algebraic sum of voltage drop across individual resistance which is equal to source voltage. So this voltage drop, I am naming it as a V1 voltage drop, and this I am naming it as a V2. So according to that statement, V1 plus V2 which is equal to V that is V source 25 volt. Again here only we are going to apply a Ohm's law. V can be rewritten as IR since that I is said to be I1, R is 5. So I am replacing that as 5 I1 plus, here also we need to check the current direction. Here it is a clockwise, here also clockwise. So I have taken this as a plus. Here also clockwise, it is also on the same direction. So here also I am taking this as a plus. So it is 7 I2 which is equal to, we have a source over here and the source value is 25, and this is my equation number 1 which I have obtained from a Kirchoff's voltage law. Now I am going to apply KVL at loop number 2. Here I need to check how many number of resistance I have. Here I have 1, 2, 3 resistance. So in that 3 resistance I need to take down the voltage values. So I am naming this voltage drop as V3, V4 and this voltage drop as V3. So this V2 we have already assigned. So here according to that statement, voltage drop across individual resistance which is equal to source voltage. The first voltage drop I am naming it as a V3. Why? Because this direction and the actual direction or assigned and actual direction both are same. So I have to take it as a plus. Again the same current only flowing through a 10 ohm resistance. This direction and the assigned and actual directions both are same. So I am writing it as a V4. Again when you come over here, the same current, assigned direction is clockwise, but actual direction on this resistance is anti-clockwise direction. You can check here. It is on clockwise, but actual current is anti-clockwise. You need not change the current direction while we apply a voltage law. That is the condition we need to follow. So based on that condition, here both are in opposite direction. So I am naming this as minus of V2 for the loop number 2. Here I don't have any source, so that I am writing it as a 0. So V3 can be replaced with 8 I1 minus of I2 plus 10 I1 minus of I2 minus of 7 I2 which is equal to 0. So if you simplify it, obviously these two are in series, so we can add it. 18 I1 minus 18 I2, already here we have minus 7, so 18 minus 7 25. So 8 I1 minus 25 I2 which is equal to 0 is my second equation. So further you can use equation solving method or a Cramer's rule method to determine unknown variable. So I will give you one trick. In that trick also you can verify your obtained answer. That is calculation method. In that calculation we are going to apply equation concepts. To go into an equation in a calculator, press mode, continuously press mode until we get it as an equation. So to get into an equation, press 1. So I have pressed it. So in the given problem, I have two unknown equations. So to get into the two equations, I need to press 2, where a1 is said to be a coefficient of a I1 value, so 5, and b1 is said to be I2 coefficient, 5, and c is said to be constant. That constant is always equal outside of that equation. So if you follow my instruction, you need not change any sign change. You can directly give input into the calculator. Now a2 is nothing but second equation I1 coefficient, and b2 is I2 coefficient in second equation. It is minus of 25, and I don't have any constant, so I am putting it as 0. So if you equal it, we will get x value, where x is said to be I1 current, and the I1 current value is 3.45 amps. And the next, if you press equal, it will give you y. Y is said to be second unknown value as I2, and this is